Okay, this is site 6 on the Anity Burn, and what I'm about to do is explain to you the different factors that might be affecting the characteristics of the river that we are studying. Before I do that, let me just remind you what did Bradshaw say our river should be doing. Now that we're quite far downstream, we should be seeing a significant increase in discharge, which it does look like we're seeing in the river at this point. We should be expecting our rocks to be getting smaller, our rocks to be getting more rounded, and finally we would be expecting our river to be far more efficient. Now, when we think about each of these 4 characteristics, does the data show us that this is happening? Let's deal with discharge first. Will the discharge have increased from site 5? Well, there's one major influence that may cause our discharge to actually drop here, and that is to do with the surrounding land use. We can see on the far bank of our river a large field, and as we are having a very hot and relatively dry summer period, farmers in this area are irrigating their crops, and what that means is they are having to artificially water their crops using sprinkler systems, and that's because there's not enough coming from the sky. Now, in order to get the water to do this, what farmers will often do is they'll lay down a pipe which will then draw water up from a local water source, in this case the river, and then that pipe will lead to the sprinkler systems on the field. Now, just further upstream from this location, we can find a pipe that a farmer's using to extract water in order to water, in all likelihood, the crops that we can see in this field. So what I would expect because of that is a potential decrease in the discharge of our river. We are also starting to move out of the harder basaltic geology, and we're about to shift into a softer sandstone rock again, which means we may be starting to lose a small amount of water through percolation into the rock. Now let's deal with what's happening with rock shape and rock size. If I walk upstream, I can show you very clearly why our data is possibly going to be doing something that we do not expect. We can see on the side of the riverbank here some very large boulders. Now, there is no way that the river is transporting those boulders, and we're also in a relatively flat landscape, so there is no way these boulders are rolling down the hillside, because there isn't a hillside. We can see the land is very flat around the river. So the question is, why do we have large boulders in the river? Why is the average rock size likely to be increasing quite significantly at this location? And that's because what the farmers are doing in the fields beyond is when they plough the field in the spring, the rocks that get drawn up from the soil, the large rocks, for example, these ones in the river, are then moved by tractors to the side of the field. And if there happens to be a river, what the farmer will often do is they'll dump those rocks, which we can see all along the bank. And if I follow this river downstream, right as I run alongside this field, I'll see lots of large boulders on the riverbanks, and some of them have actually been rolled into the river. So because the farmer's doing this, because they're ploughing up large boulders and then depositing them in the river, obviously the reason for that is they don't want the large boulders destroying their ploughs or harming their harvesters in the autumn when they harvest their crops. I would expect the average rock size to have jumped a lot. Similarly, you're probably going to get quite a spread of rock shape. We're going to definitely get rounded rocks in our river. We would expect that because we've got quite a lot of attrition happening. We've got a lot of water in our river, which should be breaking down and smoothing out the rocks. However, because of these large boulders also being added by farmers, we might get quite a lot of angular rocks in our river as well, which we would not be expecting. So I would expect Site 6 to have a range of quite angular rocks as well as quite smoother rocks. And the factor is to do with the ploughing up of rocks from the field and depositing them in the river. So what about the efficiency? Well, the river discharge has in all likelihood dropped, which means the efficiency of the channel is probably a little bit less because of the water being extracted. However, we do have quite a wide channel with still a reasonable amount of water in it, which means that that would act as a positive force on efficiency. However, because of these larger rocks in the river, that's going to be acting as an effective brake on our channel. So a combination of factors causing our river to be slower, like large rocks and the loss of water, a lower discharge, however, but an increase in velocity and a wider channel, those different factors are probably going to mean that the efficiency of our channel has not really changed from the last location. it's not increased or decreased. So, and that's because there's both forces acting to increase it as well as to decrease it.